Hi, good afternoon, everyone. Thanks for joining us. I am Laura Kinney, project planner at Vermont Electric and moderator for today's session. Welcome to the third topic in our innovation webinar series, focusing today on VEC's Control Center. Today, we will hear from several VEC experts, two Control Center system operators, our Chief Operating Officer, and our Manager of System Operations. This webinar has two parts. We'll have a live panel portion and a pre-recorded video. The video looks inside the control center, and then our panel will flesh out some of the topics from the video and take your questions. We will wrap up no later than 1 o'clock today. We are recording this webinar, and we will provide you with the recording at the end. We will also post it on our website. Okay, let's jump right in. We've got our panelists here on the screen. We've got Peter Rossi and Gillen. Peter, let's start with you. Please introduce yourself and tell us about your role at VEC.
Laura, good afternoon, everyone. I've had the honor of being VEC's Chief Operating Officer since 2017, having previously worked 10 years at another electric co-op in Wyoming in various roles, which also included managing their control center. System operations, which includes VEC's control center and its operators, is one of about 7 areas under the engineering and operations department.
Good afternoon, folks. My name is Gillen. I'm the manager of system operations here at VEC. Been here about 14 years. Over the course of those 14 years, I started out as a temporary meter reader, and then became a utility designer, and then from there transitioned into operations supervisor of the Grand Isle Line District. And as of now, I'm the manager of system operation, which encompasses our control center, our system operators, our substation, and advanced metering group.
Great, wonderful. Thank you both. We will now play a short video with the control center operators talking about their work. Please, at any point during this webinar, you can provide us any questions and comments using the Q&A feature at the bottom of your screen, and we will try to address them during the Q&A session.
Some of the most common reasons that the power goes out, wind causes power outages, it slaps power lines together, it blows over poles, depending on how strong it is. Ice and snow obviously will build up on the power lines and cause power lines to come down. Another reason is lightning. Lightning has a profound effect on our power grid. It doesn't even necessarily have to hit the power line, but it could hit the ground close and cause, fuses to blow. We monitor the wind, we monitor lightning, and we monitor precipitation so that we know when storms are coming, timing of storms. It helps us be more prepared.
We have a SCADA system that we use that gives us visibility to the equipment that we have out in the field and in our substations. So when there's a large outage or we lose a source to one of our substations, then a lot of alarms will come through. We can look at our different pages to see what might be going on. And some of our system has backup sources that we here remotely can switch and reroute where the power is coming from so that our members can get back on quickly, or we can reroute power with no outage at all that allows our members to stay on with no outage.
So if one of our reclosers in a substation opens or we lose an entire substation, this map is going to tell us instantly that we've lost an entire substation. If it's on a smaller scale and it's just a couple of members, we depend on the members' calls to let us know that the power's out, either their phone calls or smart. This is our outage map. This helps give us a very broad overview of our outages in a glance. So outages show up in colors like this. These pins are outages, and based on how many members are out, the colors change. This would be a single member. This is a 4-member, and the colors change escalating in color. So red is a large outage, probably a substation or at the very least a recloser. So we know that those are our priority outages. Without our substations being in line, then we can't restore the people downstream in those. So restoring our substations is our number one goal, and then we work down from there. Again, this gives us at a glance information. These are our vehicles. These are the crew members that are there. If we had tree crews or contractors, those would also be listed there. If they have bucket trucks, if they have pickup trucks, we can see everything all in one glance. All of the different colored lines, the yellow, the green, the red, those are just different circuits and different phases. Again, just a whole picture of our entire outage system all in one place.
There are a lot of variables of how long it'll take for an outage to be restored. One key thing that we look at from here in the office to determine how long power may be out is the location of the outage and the location of the lines in that area. Like looking at the map, are the lines completely roadside, like these three-phase lines run completely along the road, versus some of our lines go completely through the woods. We have this three-phase line that is not roadside, which an outage where the crews have to patrol that may take significantly longer than it would take if the lines are along the road. So patrolling can take longer when the lines aren't roadside, but making repairs can be very lengthy because sometimes the crews do have to walk out there, climb the poles, drag all the equipment that's needed through the woods to get where they need to be. The skills that you need to be to work in the control center, you have to be able to multitask. There's many things happening all at once. It's not, you know, one outage comes and okay, you can address that. It is 10 outages are all coming in at the same time. You're getting a emergency dispatcher calling to report there's a pole down, lines down. So you have to be able to multitask. You have to be able to problem solve, and you have to be able to think quickly on your feet and kind of troubleshoot and think outside the box. And you have to be adaptive and be able to kind of go with the flow.
Some of the challenges of working in the control center is it's a very demanding job. We work 7 days a week, 365 days a year, 24 hours a day. So holidays, weekends, we're always here. So that can be challenging. And it's not for everybody. It's not for the faint of heart. Some of the rewards, I think, being able to provide this service to the public, being able to restore outages, is a very rewarding feeling. You're doing your part to make sure that people get their power back on. I think that that's probably one of the biggest rewards of working in this room.
Great. So while the video was playing, we've received some questions coming in. So let's just dive right in. One of the first question I've got here is, what about safety after a storm? Is there anything you can share regarding personal safety during outage events?
Actually, I'll take this one, Laura. Absolutely. Our number one major concern during a storm and after a storm is the public and member safety. The one thing that I can't stress enough is the down wires, down lines, and to make sure you stay clear of those. Tendencies are you want to go investigate. That's not a good idea. We do have times when the lines can still be energized on the ground, and that is our number one concern. And please, after the storm is over, if you see these issues, these residual effects, please continue to call these into the control center and VEC so we can respond accordingly.
Isaac, I'd just like to add, that's definitely our top priority, but I would just like to add we may have trees that are touching our lines, or they may be touching our communication lines. We don't know what is energized until we have our experts come out on scene. So please call it in and our control center will get the right personnel out there.
Great, thank you both. Another question is in regards to the SCADA system. There was a mention of that in the video. What is that, and how does it help VEC monitor the system?
So SCADA stands for Supervisory Control and Data Acquisition. So the two big parts of that are control and data acquisition. So it provides our monitoring of the different areas that we have SCADA to. Melanie, one of the system operators, talked about substations. So we have SCADA to all of our substations, some of our field devices, some of our different ways of controlling the grid out beyond the substation, and our interlocks with the transmission system as well. In many of those cases, it's a two-way communication, so the control system operators can actually control the flow of power. Julianne had mentioned rerouting power in the case of an outage and those types of things. So it's a really important function and a primary tool of the control center.
Thank you. Another question we have here is how much is automated? Can an operator bring down the grid?
So I'll take that one, Laura. That's a kind of a two-part question. So most of our transmission, actually all of our transmission and substation level equipment is automated. And then some of our main feeders, our three-phase circuits that go out from the substations, are automated as well. And then as you branch out further into the distribution system, it becomes less and less automated, but that's something that we're trying to work on and adopt and bring in, so we have visibility of our entire system. And as to the point of, can a system operator take the system down? Yes, they can. They have control over some of the equipment that can cause large outages, especially your transmission, your substation level, but they're highly trained, they're professionals, and we trust them to do the job.
I'd like to just tag on, Isaac. That is true. They can take it down in a maybe nefarious way. They are well trained. They go through a 4 to 5 year training period, but also they can de-energize a circuit when needed. So for example, if there's a car pole accident or a tree on the line and our line crews or first responders can't get there in time, we can de-energize that circuit and make it safe from the control center. So I would rather look at it that they have the control to make a positive impact on our membership rather than a negative one.
Another question here. If we know what the cause of the failure is, how can we relay that specific information?
So members can always call into our control center. As Melanie had indicated, they are there 24/7, 365 through weekends, holidays, and that kind of thing. And they are trained with the proper phone numbers, contact information. So for example, if a tree or something is on communications, we know, if given the information of where that tree might be, what communications utility needs to respond, and we can make that call. The membership doesn't have to worry about that. So that's why, again, our control system operators are trained for 4 to 5 years, because there's a ton of information that they have, and they act as the spine to our entire operations for the electrical service that we provide our membership.
And to also add to that, Peter, other avenues to contact us: Smart Hub via the internet, support mailbox. So there's many ways to get in touch with our control center to report such issues.
Got another question here in regards to cybersecurity. It says here, cybersecurity continues to be a concern in many sectors today. How is the co-op managing cybersecurity as it relates to the control center?
I can start with that one as well. It's utmost, it's in the forefront of everything that we do. As we see live time, sometimes cyber attacks are constantly happening over the course of the day, the week. We actually maintain 2 separate systems. So we have our general IT business function system, and then we have our operation technology system, which includes SCADA and all the control and data acquisition that Peter mentioned before. Keeping those separate is vital because if one goes down, the other's not impacted. So that's very, very important. We go through monthly trainings that is required for all employees at Vermont Electric. And this is at the forefront of everything that we do to make sure we are keeping, one, our grid safe, and two, our members' financials safe as well.
Yeah, that's a great answer, Isaac. And I would just point out that we have a very robust process both on the IT and the OT side, so the information technology and the operating technology, to ensure that our patches are up to date, that we are constantly monitoring different security attacks that may not be coming to VEC or utilities, but are published by government organizations and the such. And we are constantly monitoring those things. So we have a very robust cybersecurity mechanism to ensure that our grid is as safe as possible.
Great. How do you prioritize outage restoration? My neighbor who lives near me gets restored before or sometimes after me. Why is that?
It's a great question, Laura. We get this question a lot, and I'm glad it was asked. So our restoration process follows a priority scheme. And the first one, as Isaac had mentioned, is to respond to life-threatening or public safety hazards. This includes trees on the line, lines down, broken poles, car pole accidents. We want to make sure that everybody is safe before we try to start restoring power. That may include the control system operators having to de-energize remotely until somebody can get there. The next part in our restoration priority is transmission lines. If we don't have power feeding our substations, any work that we do downstream from that on our distribution side, there won't be power there. So we have to fix our transmission, then our substations. Want to make sure that, again, the power is getting to our distribution system. And then we work on our three-phase circuits. Isaac had mentioned three-phase circuits coming out of our substations. And I had mentioned in the last webinar, our grid is set up like a bicycle wheel with the hub in the middle and spokes going out. So you can think of the spoke as the substation, maybe the axle is the transmission line, but the hub is the substation, and then going out, each one of those spokes would be a main line that we have to repair. After that, we prioritize our distribution circuits, the ones that come off this main line, focusing on critical facilities and medical personnel. We do keep a log on people that have medical needs that require power for their needs in their house. But we also want to make sure our first responders can respond to any issues outside of a power outage that might be going on during a major event. This would include police, fire, EMS, hospitals, medical facilities, Red Cross facilities, military facilities, sewage and wastewater plants, which were affected in these last floods, radio and cellular towers. But one that has actually popped up recently is EV fast chargers, because during a lengthy event, transportation for electric vehicles becomes extremely important. And so we want to put that in the mix of things that we are considering when restoring power. After that, we work on our distribution secondary circuits. And I think this comes to the crux of the member's question, which is why, if we're one street over, we don't get restored as fast as somebody that's maybe my neighbor. And the reason being is it depends on how you're connected to the power grid. For instance, you may be downstream from your neighbor, and your neighbor is being fed from a different way that gets restored first, like I said, coming out from the hub or the substation and working our way out. Or it may be a different feeder that has more damage on it, and we're able to route power through the feeder that serves your neighbor. So there's a lot of different variables, as Julianne was explaining, that we have to take into consideration once we receive information from the field. After that, we start working on other secondary wire and wire that's further out, and then right down to the member's house and transformer.
Great. Another question coming in. Do you have a dispatchable control of renewable resources that are not participating in the wholesale electric market and don't receive a DDP?
we'll have to defer this question to respond to that member directly via email after this webinar. That I am not entirely sure about, frankly. So
I think it's something that we're gearing up for. This is new, the industry's new, and as this distributed energy, renewable energy comes on, we're looking at ways to actually dispatch and control these things. But it's something that's new, and we're trying to evolve into that.
In the video, we heard about weather events causing outages. Are there other reasons that the power goes out?
Absolutely. As Melanie and Julianne highlighted in the video, wind is our major factor. Heavy, wet snow is another major factor. And then as you get into the summer months, lightning, and then animals and birds. So wildlife mitigation, that's an important part of our maintenance plan, is to stop that. Trees is another one, trees on the line. And then there's also the aspect, and this is the conversation that happens every day, to perform the work safely, upgrades, maintenance versus scheduled outages. So if it's a safety risk, we're always going to lean heavily towards that, and we might have to take a planned outage. So that's another factor.
and two other reasons might be a carpool accident. Sometimes that ebbs and flows a little bit depending on the time of the year and different weather conditions. So that can certainly cause an outage. And unfortunately, we do suffer equipment failures. It's not common. We have a robust maintenance plan, as Isaac had mentioned, and we try to make sure we stay ahead of issues with our equipment before they happen. But sometimes unexpected equipment failures do happen, and we react accordingly.
And to your point, Peter, about the carpool accidents, it's becoming more frequent as we are moving these mountainous off-road sections of line to the road to actually increase restoration time, but that also exposes them, the poles, to cars and trucks much more.
What technical innovations are in the future for VEC's control center to help prevent and restore outages?
I can kind of lead into this one as well. Fault location, fault distancing, that's something that we're trying to implement more of. So say a tree comes down, it reports back distance on the line and the location, and that helps us get there quicker to respond. Also, auto sectionalizing is a big thing. So instead of the operator manually have to open a breaker and refeed it or re-loop it around, having the equipment set up to do that automatically, which makes it even quicker to restore power for the members that we can restore.
Yeah, a couple other technological advancements that we're making. First of all, we do upgrades to our SCADA system approximately every 3 years. We're in the midst of an upgrade, and every upgrade has new features and new capabilities. We are kicking off a new automated metering infrastructure system that is going to be installed next year over the next 6 years. And that will have even more information coming back to the point where we should know an outage occurs before the first phone call comes in. And so therefore we're rolling our trucks and responding to outages before members are even reporting them, which is great. That cuts down on the amount of time that somebody is without power. We are also installing a number of different devices in areas as pilots to receive much more detailed information. We call it power quality level information, but this is all information that talks about how the grid is performing, whether it's high voltage, low voltage at different times of the year, and how we can respond to those situations.
Okay. I've got a question here about, let's see, when they're on the website and they see the estimated time of restoration on our outage page, they want to know how these estimates are determined and what does it mean when they change?
So we get this question a lot as well, and I'm always happy to talk to members during an event, because obviously a lengthy outage is not anything that we want. As I mentioned in the last webinar, I'm a member myself. I have 4 children, so any power interruption, I can certainly sympathize with our members. But ETRs, as Julianne was discussing, are difficult. They are an estimate based on the best information that we know. So for example, if there is not an ETR, it means that we have not even looked at that particular area, because say in the last flood or in the last snowstorm when we had a lot of tree damage, our crews can't even get through on the roads to go look at our lines. We are, speaking to the last question, we are implementing some new drone technology that can be deployed in an emergency situation. We're trying to run a pilot this year to see if we can gather information more quickly to make those estimated times better. But on a typical outage, maybe not storm related, our typical ETR is set at 3 hours. What we have in place is a process where we dispatch our crews, they get to the scene within 30 minutes. If they haven't already fixed the outage, they report back to the control center, and then our ETRs are updated. Sometimes during a large event, those ETRs get changed because they may have given a kind of a cursory view and said, okay, I think we can get this back up in a certain amount of time. But then as they're patrolling, and I think that screen during the movie was really a testament to this, very off-road through the woods, they may now find a large tree on the line that they didn't see before, and that will change the ETR. So these things are dynamic, but again, during an event, we're working 24/7 to try to get the power back on and be as accurate as we can be.
Got a question too. What are your current capabilities for remote controlling loads for demand response management? And what are your plans for future capabilities for demand load management?
So for this one, I don't want to say we just react, but our systems are set up to react rather than be proactive in that arena. So we can control demand response. We do this as part of the ISO New England grid. We receive information from them when that happens. We also have the ability to shift our load from the United States into Canada. And that helps a lot. It's kind of like having a huge battery in Canada through Hydro-Quebec. So we do this on a constant basis. Some of that is proactive, but we want to become more proactive where we're utilizing information, the technology I spoke of before, receiving that information in and then making adjustments as the grid is changing instead of reacting to a situation that has occurred. There's several pieces of software that we're installing. Sorrel Bruner had our innovation senior leader here at VEC spoke, I think, 2 webinars ago about some of that technology, Camus, and that will give us the ability to control both batteries, dispatchable resources, and the like.
I'd also like to add, Peter, too, some of our larger industrial commercial loads, some of our members can opt into a program to be part of the demand response program, and they actually will shed their load first to help the system out. So that's another thing that we can do as well.
Absolutely.
So today, is there a way that members can tell in real time based on their load which sources are being used? For example, if they're getting their power from hydro,
They
to
cannot.
know if they've got the cleanest energy possible. Okay.
So the best way to know what New England's grid is using as a whole is to go to the ISO New England website, and it will break down fossil fuels versus hydro versus other renewables. But right now there is no way to track, say, this particular electron being generated by a hydro facility and then going to this member's house. Really, the only way you can track that is if you have solar and you're not attached to the grid, then you know that you're receiving renewable resources. So we have a very blended electrical system that uses power from a number of different sources, but we do not have the technology to track specifically what a particular member is using from a particular generation facility.
Question about technology. How will the control center keep up with the ever-growing technology that we see every day?
I can start with that one. It's a growing area, right? It's a group discussion. VEC talks about this a lot. We're always looking to implement new technology to help operate the system. One of the, and we kind of touched on this earlier, is the with all the solar and the wind coming on and how our system reacts to that, we're looking for new technology to be more proactive at responding to these issues, the impacts that we see from these distributed energy and renewable resources. So that's it's something that's always in the forefront of our mind, and we have to adapt to it. And Peter, anything else you want to add?
Well, I would just, I think I answered the question when we were discussing the new technology, software such as Camus, but really that going from a more reactive to a more proactive approach in our distribution system operators, or distribution operators rather than being system operators. That's really the distinction there. It gives us that additional control. And that's the direction that we are moving in with various pieces of technology, both hardware and software.
Let's see, we've got a question here. This person is referencing Texas. They can only receive DC power from out of state. Does or can VEC produce DC power? Is the first part. Start there. And do the high tension lines transmit AC or DC power?
Okay. Good question. And I'm glad that they referenced Texas, because we, Team Vermont, that's what I refer to, all the distribution utilities and Velco. We have worked very hard on ensuring that Texas will not happen here in Vermont. So that's the first thing, is that we've been working since that incident in Texas, especially here at VEC. We're in a very unique situation in our geographical location, that VEC itself and through Velco ties into Hydro-Quebec. So that's the first thing. The second thing is transmission lines, generally speaking, are alternating current, or AC. However, because there are different regions in our system, Canada being a different region than the United States, in order to transfer power between Canada and the United States, those are DC lines. So it's a little bit more complicated than that. I'm trying just to give a high level overview, but the reason I'm excited about that is we have just implemented emergency our ability to respond to emergencies like that in Texas, where we might have a problem with the grid in the United States, and VEC can almost shift 100% of its power to Hydro-Quebec to prevent power outages, or to prevent rolling blackouts if that's what ISO New England calls for in a capacity deficiency scenario. So we have worked on this really hard, and I just want to let the members know we're in a very good spot here to mitigate any potential widespread issue that we might see in New England.
Great. A question I think maybe we covered, but the control center is obviously supported with extensive and complex computer software. Wanting to know if the software is developed in-house or out of house, purchased.
So as far as most of the software that we use with our computer systems, that's generally manufactured and comes in from outside of VEC. A lot of our internal SCADA work, though, is done internally. Our OT network, like the hardware, is external vendors, but is all designed and created by our internal operations technology team.
The other thing I'd like to point out is because we interface with Velco and ISO New England, we procure our software and our hardware from United States-based companies. So that is something to consider, is that we want to make sure that it goes through a rigorous cybersecurity process. And so if we do use external software and hardware, it is United States-based.
I have another question coming in about a little bit about rates. I'll ask it, but we may need to get back to this member. They're saying California now has real-time use rates for residential customers. Do you have a prediction of when VEC might offer or require real-time pricing for residential customers?
Topic that has come up, and I think this one would be best addressed afterwards, because it is a complex issue. Any kind of rate structure and change, of course, has to go through the Public Utility Commission and other state agencies, as well as be relatively consistent across, all distribution utilities. So I would hate to make a prediction and it not coming true. So I'm going to defer this one to maybe a response afterwards in a more consolidated way.
All right. Well, that is it for the questions that have come in so far. In closing, I'd just like to ask a question. And that is, what is one thing that you wish members knew about the control center?
I could start first. It's a tough job, or can be a tough job. It goes from 0 to 100 miles an hour in the control center in the split of a second. And that the operators are professionals, are trained to respond accordingly, and that they're going to do their best, and to please have patience when dealing with the control center. So, Peter?
I think it's great. I'll just tag on to what Isaac said. Melanie had mentioned this, that it's definitely not the faint for heart, and they do a lot of work behind the scenes to make sure that things are working, members have their problems solved, and they're there all the time. They make a lot of sacrifices with their families and their loved ones, and sometimes have to defer holidays and vacations to make sure that our system, when we go home for the weekend, there's always somebody in that control center, and that makes me feel really good. And so again, I like what Isaac said is, please, when you call in, we realize it's an emergency. We're going to take it seriously, but be patient. They may be dealing with 3 other emergencies at the same time. They're there 24/7, 365, and are the heartbeat of this company.
Thank you, Isaac and Peter, for your time today. That wraps up this session. Thanks to everyone for joining and engaging with us today. If we didn't get to your question, which I think we got to all of them, we will try to get back to you via email. As a reminder, we will send out a link to the recording of this webinar, and you can also find the recordings of our previous innovation webinars on our website. Look for another topic that will be coming out this fall. We hope you found this webinar interesting and informative. We hope you have a great day. Thank you.
Bye.
Take care, folks.